Okay, so moving on from scandium, assuming you are watching these in order, I thought I would take the opportunity to segue from the contributions of Lars Friedrich Nielsen, the discoverer of scandium in 1879, and start this video with his involvement in the origins of titanium. 8 years later, he was able to get titanium pure as 97% via a chemical method. Anodizing titanium works by making the titanium the anode in an electrolytic cell, where an applied voltage causes oxygen to form and build up a thin, transparent oxide layer on its surface. The layer's thickness changes with voltage, producing interference colors. It was first discovered in 1791. A geologist named William Gregor took some sand from the banks of a stream in Cornwall in the south of England. It was attracted to a magnet. Studying the sample, he found two oxides, one being iron oxide, the reason behind the magnetism, more specifically its unpaired electrons. The other oxide, however, was something new, and as you might guess, this was titanium dioxide, the white substance. Titanium was deemed a strategic material during the Cold War, and the USSR, most famously, it was used in the Alpha-class submarines. Experimental high-speed subs with titanium hulls.
Soviet titanium technology was far in advance of the West.
Titanium allowed them to dive deeper, move faster, and resist detection better than conventional steel, giving the Soviets a potential edge under the Arctic ice. In 1795, Martin Heinrich Klaproth independently rediscovered and named titanium after the Greek Titans. For a long time, titanium was only found in laboratories. This is because its chemistry was a challenge. The traditional method of using charcoal to reduce an oxide into a metal proved unsuccessful for titanium. The metal oxide is put into a blast furnace with charcoal, which is carbon. The carbon sequesters the oxygen from the oxide and leaves as carbon dioxide, and what remains is the metal. In practice, it is not just the metal oxide that is into the furnace, usually we have a metal ore, which is a rock containing silicates. Calcium oxide is used as a flux. This reacts with the silicates to form calcium silicate. This is what we call slag. As I mentioned, this process does not work for titanium, as its high affinity for carbon meant it would result in a hard and brittle titanium carbide. Although titanium carbide has found many uses as a hard refractory material, good for metal cutting tools, high temperature aerospace composites, this was not the pure elephant Klaproth was looking for, and it was also not the element he was looking for. It was not until 1887 that Nielsen, in collaboration with Patterson, discovered that heating titanium ore in a stream of chlorine gas would produce a liquid called titanium tetrachloride. Titanium tetrachloride is a yellow, transparent liquid. When it is exposed to moisture in the atmosphere, it hydrolyzes forming thick clouds of hydrochloric acid vapor and aerosolized titanium dioxide. Titanium's emission spectrum and the color of its fireworks are white. Titanium dioxide, it has many uses, mostly because it is very white, very colorless. Some forms of it are black, but generally it's very white. It is used in cosmetic products. It is used in sunscreen because of its UV resistance. It is used in paints. It is used in plastics. It is an N-type semiconductor. It is non-toxic, non-flammable, and insoluble in water. This could then be reduced by sodium metal to obtain metallic titanium. In the years following, his method was refined. Calcium was used, and finally magnesium. Green on this side, and red